Kia ora koutou. This is a question for Nikhil about confidence intervals, and it's a really good question to go over the idea of the standard deviation of a sample proportion. I'm going to also do some work in this video on confidence intervals for the sample mean just while we're at it. Okay, so it goes like this. We've got a random sample of 75 students at a large college. 15 of them said that they owned a car, and from this result, an approximate confidence interval for the proportion of all students at the college who own a car was calculated. So what we're doing here is we're trying to build a confidence interval for P, where P is equal to the population proportion. Okay, but we don't have the population proportion, we just have the sample proportion, which is P hat. Now P hat is equal to 15 out of 75, which is 1/5 or 0.2. So what we need to do is to surround that by a range of values where we can be pretty sure that the true value of the population proportion lies. So in the middle of my confidence interval is going to be 0.2, and then on either side of it I'm going to put a thing called a margin of error. Right, so we're going to have plus on this side and minus on this side. And we've looked at this in class briefly, but the idea here is that we're going to have P hat plus or minus a value that comes from my normal distribution, which will be z alpha on 2, and then times this, P hat times 1 minus P hat divided by n. Right, so this is the standard deviation of P hat. And that's because P hat is distributed roughly, normally. Its mean is the true value of the population proportion, and its variance is P times 1 minus P over n. Right, so the standard deviation of P hat is going to be the square root of this thing. But we don't know what P is, so we have to estimate it, and that's why we've got the P hats in here. Okay, so that's how I set my confidence interval up. So let's see what we can do from here. Well, we're told that the width of the confidence interval is 0.162. So we can say that P hat is equal to 0.2. So here's 0.2. And that whole width of the confidence interval is 0.162. That means that the margin of error is equal to a half of that, so it's 0.081. And now what I need to do to figure out the significance level, or that's what they've called it, that we're working out what is alpha percent. So we're doing a confidence interval. So we're going to work backwards from that margin of error. We know that 0.081 has to equal the z value times the standard deviation of P hat, which is going to be 0.2 times 1 minus 0.2 of 0.8, and n is 0.75. So let's just go over again where that comes from. Well, it comes from in here. This is my variance, P times 1 minus P divided by n, and so my standard deviation is the square root of that. Right, so now all we have to do is just to do a little bit of reverse engineering. So we've got z is equal to 0.081 times the square root of 75 divided by the square root of 0.16, which is 0.4. And what does that give us? Well, we get a z value of 1.754, and that's to 3 dp. What do I need to do next? Well, I know that my confidence interval has got this value here, 1.754 here, and negative 1.754 here. So my significance level is going to be this area here. So if we go to our normal tables and we look up phi of 1.754, that's not going to give me exactly the right answer, but it's going to get me to a related answer. So phi of that works out to be 0.9599, and then when you do the little add factor, I added on 4, so I got 0.9603. What that's telling me is that that's roughly 96%. And that means that I've got 96%, but that goes all the way back there. What I'm interested in here is not the 96%, but what's chopped off in that tail, which will be 4%. And that means that I've also got, let's get rid of all that green, I've also got 4% in that tail. So my significance level is going to be 100%, take away 2 lots of 4%, which gives me 92%. So alpha in this question is equal to 92. So while I'm there, I'm going to talk about confidence intervals for the mean because they fit a very similar pattern. Right? So for my confidence interval for a proportion, the middle of it is going to be my sample proportion. So we'll just come back in here. Let's just look at the two cases. So we have p hat plus or minus my z value times my standard deviation. The counterpart for the mean will be my sample mean plus or minus my z value times sigma over root n. Okay, and that's because the sample mean is distributed roughly normally with, on average, the population mean and a variance of sigma squared over n. Now we've still got to spend some time talking in class a bit more about when this holds up, but basically for a large n and a known sigma, this result is true. When we don't know sigma, then in theory we've got a t distribution, but we don't need to worry about that because the t distribution and the normal distribution are just about exactly the same when we have n bigger than, I don't know, I can't remember, it's about 20 or 30. They start to look incredibly similar. When we have a very small sample size, the t distribution has really fat tails. And as I said in class, you don't need to know about t distributions for A level, but I think it's a really cool part of the puzzle to make everything fit together. Okay, so two different kinds of confidence intervals that you need to be confident with, excuse the pun, one for the sample mean and one for a sample proportion. Nikhil, thanks for sending in the question. That was a really good revision question. So just keep the emails coming, guys, and I'll try and do them when I get time.